Hi, welcome to the week 13. That's the last week of the semester. So today we will discuss unit testing with the JUnit. So this two-part. One is the introduction to the Eclipse. I believe most of you may already know. Use the Eclipse in your 285, in 375 or other courses. So for this part, I will just quickly go through them. How to how to install the where to download and install the Eclipse and configure Eclipse. So I already put in this quite intuitive slides. So these slides are quite self-explained. I won't go to the detail of the Eclipse. So I believe as a computer science student and software engineering student, you should be able to download the software and install it and configure the IDE and make it, and then go from there. So what I focus is on the JUnit, and I found out that this JUnit topic I already discussed extensively in my 285 course. So in that, I also designed a lab so that a student can practice the JUnit. Probably it's a good idea to just post the 285 video on the JUnit and guide you guide you step by step how to configure the JUnit and then the concept of the JUnit and then write the test cases in the lab. I will also post the lab. So basically, you will see the video of the JUnit, and I explain the 285, the lab line. So you just follow step by step and finish the lab. So if you can finish the lab all by yourself, which means you won't have any problem for your final exam. So a big part of your final exam is I give you the code, and then you identify the anti-pattern, and then apply the refactoring to the anti-patterns, and then after you make a change to the code, you need to test the code, right? But yeah, then you write the JUnit test cases to make sure that the change of the code you made doesn't affect, doesn't introduce any new defect. So you need to know how to write the JUnit test cases. So that's why I post this 285 video, and also I guide you through the lab so that you can get a practice on the JUnit. So if you are already very familiar with JUnit and use JUnit extensively with Eclipse, you may just skip the rest of the video. And then the next topic in the future is the black box and the white box testing. Okay, now let's go to the video in the 285. The unit test case is a piece of code. So remember that the unit test case are code. So you need to write the code to test the code. And the unit tests are performed to prove that the piece of code does what the developers think it should do. And this one is a proven test-driven way to improve the quality and this SQA requirement saying that you have to run the unit testing before you check in your code into the repository. So you have to pass all the unit testing before you can check in the code. So the unit testing is the first, the safeguard we need to go through to ensure the quality of the software. And this shows that what we focus on and we don't do in the unit testing. During the unit testing, we are not concerned about the formal verification of software. This one is so far away from the source code. And if the program does the right thing according to customer or end user and the performance issue of the software. So it seems, we, I mean, it's too far away from the source code. The source code is we will only during the unit testing we test only isolated one small part of the software. We cannot use that small part of the software to answer the verification performance of the software. We cannot do that. But during the unit testing, we focus on like proving the code does what we intend to do, and test very small and very isolated piece of the functionality, proving the unit tested code work before we move on to the next coding task. So we test small part, and we don't look at the big picture of the performance, whether the software is customer one. We don't do that. And what should be tested then? So here we need to test for the boundary condition. So here we're talking about the data. What data we need to provide to the software to test. So we're talking about this boundary condition later on, and then we test for both success and failure. Sometimes we write the code intentionally make software fail to see that how of or the data we provide is invalid, and we see how software responds to the invalid input, for example. So here is this different approaches we can do to when you're writing your unit test case code. Then how we do the unit testing? You decide how to test the method in question. You do this before you write the code. So when you write the code, you are the developer. You know what you try to do, what you try to achieve for example, in this class or in this method within a class. Yeah, and then you know what you try to achieve in this method. Then before you do that, you may just write the test case before you write in the code. So that's a very good way for you, for you to pass the unit testing. And you run the test yourself, and you inspect all test results and determine whether it's all work. So here you have all the test cases. When you write the code, you write the test case as well. And then when you finish writing the code, you run all the test cases automatically to make sure it's passed. So this the coding and the unit testing are the responsibility of the developer. Okay, so this gives you the interactive software development. So here we write the testing, we write acceptance testing, and then we write and run the unit testing, and then we do this iteratively, make sure that the code you written pass the testing, pass the unit testing, and then you move on. Okay, so this gives you the unit testing tools. Depend on what programming language you are using. There's the unit testing tool for any programming language you use. For example, like JUnit for Java and NUnit for C#, CPP plus or Unit plus for C++. So here, there's so many unit testing tools we can use. So in our lab and in our class, we will introduce the JUnit for Java. Okay, let's see the testing with the JUnit. So JUnit is unit test environment for Java program. So if you use the Eclipse, and then it is already in there. When you download the Eclipse, the unit testing, the JUnit is already there. So this gives you the test framework. Suppose this is the production code. Yeah, this production code the method is called the double of 2, and then your testing code is to add the keyword test in front of it. So this is just the test is also the code is test double code, and then you in here you will call the double you'll call this code, and then you verify, and then we use assertion to verify, and then later on we are talking about assertion. So this is the JUnit the code, what the code looks like. So the okay, let's do this. Okay, suppose this is a part of the software. This is a component consists of 3 classes, and this component is connect to other component. There's a classes in there, and so on. And so there's many many black box component. And on the top one is the is a user interface. And so all the from the software point of view, the user interact with the user interface, and then eventually the call forward to certain classes. And you suppose you are working in the class 3, and this one is a very buried deep into the software. So to run this part, to touch this part, you have to go through the user interface, have a certain input, and then then it's very difficult to touch this part. So the unit testing is to call this method directly from is to call the test M1 test M2, and it also has a class called test C3. So this is a replacement of the main program. Instead of starting from the user interface and go through different level and then eventually reach this method, I can have a unit test case. I mean the JUnit class as a replacement of the main program, starting from here to test M1 and M2, so that you can test M1 and M2 more completely. So you can design data here to test M1 and M2 more extensively. It's different from the user interface. You can only test this one limitedly, but with the unit testing, I can test it more completely. So that's the this JUnit is a replacement of the main program. Is a replacement, for example, replacement of whatever you put in here, and then a relay in here. The data you put in here, and then eventually relay to the M1 and M2. So here you can feed in the data directly here, and to test M1 and M2. Okay, JUnit is a substitute the user main to check the program behavior, and all we need to do is to write a subclass. All we need to do is write a subclass of test case. We write this class, and then we add one or more test method. So here we have a test method. If we want to test M1, we have a test method 1. Want to test M2, we have a test method 2. So here we add one or two test method. Then we run the test using the JUnit. And so the JUnit is the test environment that we can for the software. Instead of starting from here, we can the JUnit environment allow you to start from here. Okay, so the framework has this element can be a single test case, and this is a base class for class that contain the tests, and then how we do the testing. So in here we use the assertion to check the condition. So think about like for any method. Okay, for example, like here, for any method here, if you give an input of this method, you expect some output. And then assertion is to see that when I fit the testing data, do I actually get what I want? So here the assertion will do the comparison. So there's a different assertion method you can do, but all of them is to check what you expected and what's the real, and then to check the expected and the actual. If they're the same, then assertion pass. If they're not the same, then the assertion aborted. Then if the assertion aborted, it shows that your unit testing failed. And test suite, since all the, and this will allow you to run a group of test cases, and this will, when you have the several test case in a test suite, then you can run this test case automatically. So you think about this, unit testing is when you click on I run a unit testing by grouping the test case into different test suite, and then you have a list of test suite to run, and then you can just run all of them automatically. Okay, let's see how to write the test case. To write the test case, this one shows that you need to first include this JUnit framework, and then for the class, create a subclass of test case which add a test method. So this text XYZ extend the test case is a subclass of the test case, and then the JUnit will know that you are going to test XYZ class. When you add this test keyword, then the JUnit know that this class serve as the main function of XYZ. So in here, when you add the test C3, test C3 is a subclass of test case. So the test case is a base class of JUnit. So when you add a keyword test here, then the JUnit knows that this class is a subclass of test case, and then this test case is used to test C3. Then it will connect these two together for you. Okay. The next is assertion. Assertion, as I mentioned, is to check the actual and the expected. So there's a different ways for you to do the assertion. So let's see that there's assert true, assert false, assert none, assert non-none, assert equal, assert same, assert not same. So let's go through them one by one. Okay. First, let's see the assert equal. So this one is to check the expected and the actual, and with the stream message, if the expected and actual are not the same, then this warning message will show up. So here I give you an example: assert equal is the wrong answer to check A and B. If A is 2 and B is 1, then this will show the wrong answer. So this assert 2 equal is to check the expected and actual variable. Are they the same or not? Assert none is assert that given object is none, failed otherwise. So here when you assert none is to make sure that this object is none. So if this object is not none, then this assert fail. Assert non-none is just do otherwise, and given the object is non-none, fail otherwise. And the message is optional. Assert same, this also refer to the object. So that the none and non-none apply to the object. So here you have to fill an object. So assert same and not same is also, the expected and actual here actually refer to the object. So we'll see that we have assert same and assert equal. So the equal or assert equal, we're focusing on the variables, and the same we used to compare object. So here we just if the expected and the actual are refer to the same object, then this pass, otherwise fail. The not same is still otherwise. So if actual and expected are not the same, then it's pass. If they are the same, then fail. Assert true is to assert a Boolean condition, for example, like a if statement. So whatever, a Boolean state, a condition, if it's true, then it's assert true pass. If it fail, then it's if false, then it's fail. Assert false is to assert this condition false, and then fail. So this one is will fail the test immediately with an optional message, and typically used to mark a section of code that should not be reached. So if some part of code you don't want any circumstance will go through that bunch of code, then you can put a fail there. So when the software when you're running the code somehow reach that part of code, it will show the message. Assertion issue. So in here we have we introduce a number of assertion, and so it's very common that multiple assert in a given test method, and the one assert fail, that test method is aborted. So the remaining result will not be executed. So make sure that all unit tests pass every time you run a test case, and avoiding adding any new functionality if you have at least one fail. So the JUnit is designed in a way that one assertion failed, then the entire execution is aborted. So this forces you to look into the issue, make sure that one passed so that you can move on. Okay, let's look at one example here. So here we have a test case is to test largest class, and in the largest class we test a method called we call the largest using the assert equal. Okay, so in here you see that I fit the largest method. I mean, this one comes with the largest method. I test the largest method. I fit this array A97, and this one is return from the production code. So what I expected from here is I expect to return 9, and then if I fit into this data, and if the production code actually return 9, then it's a assert pass. If this one doesn't return 9, then this assert fail. Then I know there's something wrong with the code. Yeah, because I know that by looking at the array, I know that the largest number is 9. But if the code return otherwise, then I know there's something wrong with the code. So here, the A97 is the testing data. So from here, that from the testing data, you know that we can choose different kind of data. Yeah, so theoretically we can choose unlimited number of data. So what data we should choose? Should we choose? Is it good to choose as many data as possible? The answer is no, because if you choose so many data, if the data are all from the same type, you're actually not serving. It won't increase the chance for you to find defect. So what data we should choose here? So here we introduce the boundary value analysis. So in other words, we choose the data in the boundary because we believe that data in the boundary are more likely to fail. Yeah, for example, if the data here are the integer, now we know that the integer, if this integer can be negative and positive, then we can choose 0. For example, like a 0 is is in the boundary. Then we choose a -1, +1. Just one below and one above the boundary.
And then another boundary is all, I mean, the positive maximum. Yeah, we know that the positive maximum, and then the negative minimum. So we can choose, the data from the middle to the negative boundary and the positive boundary and some data in between. So this is so when we choose the data, we keep this boundary, idea in mind. Then we can choose the data more likely to find a defect. So the boundary value analysis is a way to generate test case, to actually more specific to generate test data. In here, here we can choose 7, 8, 9. We can choose a -1, 0, and 1, and we can choose the data around the boundary, the maximum and the minimum. This is how we choose the data using the boundary value analysis. Yeah, for example, if the data the input data is an integer, we can choose like a 0 is a boundary, and a minus data and the plus data. So in here, if the data has involved two integer x and y, and here we have a range of the x is between x1 and x2, and y is between y1 and y2. So here we have two input data. Then we can choose these 14 data for the input. So the data one is right in the corner here, because we know the x is between x1 and x2, and the y is between y1 and y2. The x1 is in the corner right within here, so is a valid data. And 2 is in this corner, 3 in this corner, 4 in here, and the 5 is invalid data. We see the 5 is outside the range. 5, 6, 7, 8 are all invalid data. Sometimes we want to choose invalid data to see what's going on. And the 9 is the data within the boundary. So this one is represent all the data within the boundary. So if 9 passed, so we assume that all data within the boundary should pass. 10, 11, 12, and 30 is on the edge. It's on the edge here. And 14 is the data way outside. So in here we see that we have within the 14 data, we have 5 invalid and 9 valid data. So this is how we choose data. So in here we have x on the y two variable as the input. Then we can come up with the 14 test data. So in here is like we run 14 assert. We can run 14 assert here to see what's going on. And also we can apply the variable to the output. I mean, we can apply, and the BVA can also apply to the output variable. So here, if we know the output data follow some pattern, then we can apply the same strategy to the output variable. Okay, let's go over the lab. So for the lab 9, you have up to the Thursday night to finish. First, need to create a new Java project, and you add a new class, the largest Java. So I give you the code, and of course this code is for you to feed an array, and suppose that array will return. Suppose this largest method will return the largest number in the array. So that's the purpose of this piece of code. And of course, this code has some error. And so I ask you to test different scenario. And then if you choose the data right, if you choose the right data, then this assertion will fail. Then you know that there's something wrong with the code. So in here, I don't want you to first do the review. If you look at the code, of course, sometimes you can find defect, but the purpose here is not for you to review the code and find defect. I want you to practice choosing the right test data and the right assertion and run the assertion, and if and fail. And of course, this if the code should fail if you choose the right assertion. And then you come back based on the assertion result. You see what's wrong with the code. Then you make change to the code and then run the test case again. If you fix all the defect, then the assertion, this test case, the test case should pass. So this is production code. This is production code, and this is the a part of the code in the JUnit. I need you to add the data and to write more test cases. So in here I have three test cases. One is to test the positive. Yeah. So from here we know that the test largest. Then we know this JUnit class is to test this class. So this one is like the main function, is like a client code, like the main function. So in the main function, the test is the one. So when you run the JUnit, it will run these three test cases. And I first comment out the test negative and test the mixed, because in here I ask you to add the JUnit code here, but the test positive already have some code, so you can use the same format, just change the negative and make the mix, have both positive and negative, and you write it here. But before you write it here, please keep these two common. But once you finish the test negative and test uh, mix, then you can remove this comment. Remove this, then it will run all three test cases. So the first, you run test positive. So means all the data, all the array you put in here are positive number. And then here you create a largest object, and then you call the largest method, and you have the maximum value return from this method. And then here you need to add an assertion here. So this is your job. Okay, I'm not going to tell you how to write assertion. So please, so here you have to do some research and all by yourself to write the assertion, because we discuss assertion. Yeah, you write the assertion here to compare the actual. So this maximum value is the actual. And then just by reading this array, you know the largest number. The largest number in the array is 10. So you just compare if this maximum value is 10 or not. If it is not 10, then you know this code has something wrong. Yeah, if it is 10, then you know it passed this test. Then test negative is to make them negative. Now it's all positive. So here you just copy and paste the whole thing here, copy whole thing here, then paste here, then make it negative, and then you compare the maximum value. If they're all negative, then the maximum value should be -2, right? Yeah, for example, if you just add a minus sign in front of them, then you know the maximum value is -2. Then you check if this maximum value is -2 in the assertion. If it is -2, then you know pass assertion. Mixed shows that it has both positive and a negative number. That's up to you. So here I want you to prepare the three data. Three data. One is all positive and one is all negative, and all is with both negative and positive. And after you have the negative and positive, then please uncomment these two so that it will run all three test cases. Okay, so what you do is add the production code, then add a JUnit test case, test Java, largest.java, and you're working on the three test cases. Yeah, we have test positive, test negative, and test mixed. Yeah, and test mixed contain both positive, negative, and zero. Yeah. And some tests in here should fail, and this indicates there's something wrong with the code. And then please fix the code, and then rerun the test and make sure all tests pass, and then that's it for the submission. You show the output of the unit test, including both failed and passed. So when you fail, please take a screenshot. Something to show the evidence that you write the test case and it failed. And the final output of all unit testing showed a success pass for all, and then and then the source code of the final test largest and the source code of the corrected, yeah, of the final largest code. So this is the what I want you to be included in your submission. Okay, I think that so this is J. We know this JUnit targeting Java code. I mean, the code itself is quite simple. Even you don't understand, even you're not familiar with Java or never code any Java program before, but for this Java, it should be easier for you to understand it. Yeah. Okay, I think that's it for today, and I will see you next week.